Here we go. All right. So when we have, any kind of form of an equation, we all remember that there's some standard form thing there, right? All right. So this A is the amplitude. And we said back there that the amplitude was half the distance between the max and the min. How far up and down does it go? Right? So that's the amplitude, and it's the number that sits out there. The B, we haven't really done yet, but we're going to. The B is a dilation, and put so that B equals 2 pi over P. Whoops, don't write that. Or P equals 2 pi over B. All right, so the period is, should I write something? P is period. So how long does it take for me to go one complete curve of the sine? One time. One time around the circle is the period. That's going to change in a couple minutes when we do a problem, okay? Yes? A P. P as in Peter, capital P. I know, I didn't write that initially, that's why it looks so bad, okay? And this is a B. It's not a 6, it's a B. Okay? It's a B. B as in batter. That B. Okay, the C is a horizontal shift. And the D is a vertical shift. Go, let's graph one. So, what's the amplitude? 3. So when I start drawing, I know I'm not going to just have 1 to 1. I'm going to have 3 at least. What's the shift, the vertical shift? Up 1. So this thing, when I'm looking at it, I have to take a breath before I start graphing and go, okay, it's 3 up from the middle, 3 down from the middle, but the middle, or what we call equilibrium, is 1. So I'm really going up 4 and down 2. Okay, so the middle of the graph is now at 1. That's the first thing I put on. So I kind of work from D up, okay? So it goes up 1 from 0. All right, so I got 1 here. And that's like my new x-axis. Okay? Because I'm moving up 1. Now, from 1, I'm going to go up 3. So I'm going to go 1, 2, 3, and I'm going to be up at 4. And I'm going to go down 3. 1, 2, 3. So I'm going to be at negative 2. And the next thing I need to do is say, I have a 1 in front of that x. That's good. That means I don't have any dilation. And so, or I don't have any shifting this way or that way. So now I'm going to put my markers on. And I have to get these 4 markers on. So I'm going to go to there, to there, to there, to there. I'm just going to put them on, because I know I always use those markers. But really, they're going to be marked now on this line, because that's the center. That's my equilibrium. Here's how we go. When I'm at 0, I'm at 1. Okay, start on equilibrium, just like I did before. Pi on 2 is when I went up, right? But now I'm not going to go up to 1, I'm going to go up to 4. How does that happen? Because that's 1, then times 3, then plus 1, yeah? Then I go back down, it looks exactly the same. I go back down to equilibrium. Then I go back down here. And then up to equilibrium. So it's the exact same graph. It's the exact same graph. It's just shifted. So when we start this, we go, okay, that's the only thing that changed. So I'm going to use that thing up there and say, you know what, the period is going to be 2 pi over b. The period's going to be pi. So when I wrote that up top, it was a big deal. And I think maybe what we should do is go back up to the top and put a pink box around it. The period is 2 pi over b. It's a big deal. That's not on your formula sheet. So I go, okay, what's going on now? The amplitude hasn't changed, but the period has changed. And if I'm going to go up 1, down -1, that's my y. This is my theta. Now if I go, okay, I've been going out to 2 pi. Can I make it long enough? Not really. I'll make it a little bit longer. I've been going out to 2 pi, and then this was pi, and then I used my 2 other markers, halfway and halfway. All right. Now what I'm telling you is this entire graph, the sine curve, is going to fit in here. So, I'm telling you, you need to have 4 because of this. Because of 1, 2, 3, 4. I need to put those 4 down. I need all those boundary values to get the whole curve. So here I go. This one's pi on 2. What's this one?
Pi on 4.
Yep. Pi on 4, 2 pi on 4, 3 pi on 4. Okay, let's just put those in for now because we're running out of time. So when I put pi on 4 in there and multiply it by 2, I get pi on 2. See what I'm saying? So this is how it works. It's a sine curve. It starts at 0, it goes up, it goes down, it goes down, it goes back to equilibrium. It just went like that. So multiplying by 2 here squished it into a half of its space. And I could just keep going. So in 2 pi, I get 2 periods. 1, 2.